video explores the asymmetric Markovian kernel and how broken detailed balance generates a net forward probability current. This mechanism is central to stochastic pump theory, non-equilibrium statistical physics, and models of directed transport on lattices. You'll learn to interpret edge currents, understand the Tesla valve routing effect, and connect kernel asymmetry to torsional lattice dynamics. We'll see how the asymmetric kernel, K sub p tau, breaks detailed balance. Backflow gets trapped in self-impeding loops, like a Tesla valve. The result is a strictly positive net current J that drives the 12-channel clock forward. Let's work through it on the diagram. Phase 5 of the TTMPT introduces the asymmetric Markovian kernel. 3 colored streams flow forward through a lattice of triangular veins, while dashed backflow paths curl into closed loops. This is a stochastic Tesla valve. Most stochastic systems obey detailed balance, meaning every forward jump is matched by an equal backward jump. That gives zero net current and no arrow of time. The pump must break this symmetry without destroying probability conservation. Goal: show how the kernel K sub p tau produces a strictly positive current J and connect it to the 3 nested streams of the 12-channel ring. Recall: detailed balance says forward and backward edge probabilities are equal. Define the edge current J sub ij as the difference between forward and backward probability flow. If the chain is reversible, the 2 terms cancel exactly. Then every edge current vanishes. A reversible chain has no preferred direction. The clock would stall, so the pump must break this symmetry. Watch what the Tesla valve geometry does. The asymmetric kernel K sub p tau makes forward and backward transition rates unequal. Forward rates dominate backward rates on each edge. Any probability that tries to flow backward gets routed into self-impeding loops by the vein geometry. On every edge in the preferred direction, the difference is strictly positive. Detailed balance is broken without violating probability conservation. Now sum these positive edge currents around the ring. Total current is the sum of edge currents over the forward edge set E+. Add up the positive edge contributions around the 12-channel ring. Every term in the sum is strictly positive thanks to the kernel asymmetry. Therefore, the net current J is strictly positive. The 12-channel group C12 gives the geometry. The positive current J supplies the arrow of time. Together, they form a torsional drive. Whenever you see a stochastic system with a preferred direction, look for broken detailed balance. The asymmetric kernel routes backflow into self-impeding loops, leaving a strictly positive net current. This single inequality is what turns the 12-channel ring from a passive phase wheel into an active torsional drive.